Hi, everyone. My name is Tammy, and today I'm giving a presentation over a project that I'm currently working on. It's to build a risk assessment framework to assess stablecoin risks from different angles. And in the next 20 minutes, I'm going to cover the motivation and then the project goal. What are the different stablecoin risks being identified in the risk assessment framework? And what are the challenges of having assigning an overall rating to stablecoin at the end? Yeah. Yeah. Well, they're trying to fix the machine issue, but I can give a little bit background about myself. So, it's working. So about me, I'm currently working in a crypto exchange, specialized in blockchain analytics. Before that, I was a credit risk modeler for wholesale banking. And if you are interested in Oracle design, I also have a research paper being published recently. It's about relationship between on-chain and off-chain market data. And about this project, it's a personal project that independent from my current employer. I started about 6 months ago after receiving a grant from Ethereum Foundation, and it will be completely open source after it's done. So before getting into all the details about the different risks that exposed to stablecoin holder, I would like to review the 2 significant stablecoin events that happened in the last 2 years, because we're going to use them as an example when we analyze the risk. The first one is the famous fall of Terra. So what happened is it started with UST slightly depacked after the market saw a large amount of USD deposit being removed from the Anchor protocol, as well as a large amount of UST being dumped into the Curve 3 pool. LFG, which is the Lunar Foundation Guard, tried to recover the pack by selling BTC, but it wasn't successful. At the time, there are 2 ways to exit for UST holder. One is to sell UST to the Curve UST 3 pool, and then the other one is to burn UST by minting Luna. Then, if anyone has a little bit knowledge about how UST works, you know that it is backed by Luna, which Luna does not have any other use cases outside the stablecoin systems. So when UST's demand is up, Luna's price goes up. And when UST demand goes down, Luna's price goes down as well. In the crisis of confidence, more and more UST holders want to exit. And then, Luna and UST went into the death spiral. So just in a couple of days, UST and Luna UST's value dropped from $1 to below 10 cents. And then the next significant stable event was triggered by the collapse of the Silicon Valley Bank. In mid-March this year, then the SVB has been shut by the US regulator, and then all deposit withdrawal has been halted. Some USDC holder got worried because SVB is one of the custodians for the USDC's cash reserve. So they sold their USDC. As at the time, it's not clear that what is the portion is stuck with SVB. USDC went depacked, and followed by other stablecoin who has direct or indirect exposure to USDC. Like DAI is one example where DAI enable 1-to-1 swap for USDC to DAI in its peg stability module, PSM, we also saw a run on the, so we also saw GUSD and USDP reserve in the PSM has been drained, which is shown in the diagram here. And then the Dune diagram shows the token breakdown for the Curve 3 pool during the DappCon weekend. Then you can see large amount of DAI and USDC has been dumped into the Curve 3 pool. So on Sunday, Circle revealed that only a very small portion of USDC's cash reserve is stuck with SVB. Then USDC's value starts going back. And then on the following Monday, FDIC promised that all the, they will enable all the deposit withdrawal for SVB. Then the USDC is back to $1. From the two examples we just went through, we know that the two general concern arises from holding a stablecoin. One is the risk that stablecoins significantly depacked and has a negative impact to the wider ecosystem. In this scenario, the value of the stablecoin may go back to the pack, like the USDC example we walked through. Or it can also be the case that stablecoin holder may suffer from the haircut. And then the second concern is the risk that the entire stablecoin project collapse. In this case, value of the stablecoin cannot be recovered, and that's the UST's case. And then the third concern hasn't been demonstrated in the two examples, but has been discussed quite frequently, is the risk of user being censored from using the stablecoin. That can be done by a centralized party who control the stablecoin. In this case, the value is there, but user cannot access to the value. There's many in-depth stablecoin risk analysis, but for common stablecoin holder, these are the metrics that they use the most, and then the most easily accessible. To compare stablecoin project, they use market capitalizations, circulating supply. And then you can have metrics that are not as easily accessible, but has been mentioned in many stablecoin-related discussions, like historical price volatilities, value of collateral, liquidity, and the incentive to hold. But if you think about the two cases, then for Terra, the trigger of the Terra, the failure of the Terra, is because there's a fundamental flaw in their stablecoin system. They are under-collateralized by design, and they use Luna, which has a circular value that can go down to 0. And for USDC's temporary DePack, they are fully backed by cash and cash equivalent. That's what people know. But its temporary DePack was triggered by the custodian risk they are exposing to, which the custodian risk, the cash reserve exists as a banknote. So with all these metrics on these slides here, even the combination of them are not enough for analyzing stablecoin risk. So this is my project's goal. I call it SRAF, Stablecoin Risk Assessment Framework, to build a multi-dimensional stablecoin risk assessment framework to measure stablecoin risk from different angles. And then it's easy for common stablecoin holder to assess the information, and then easy for them to compare stablecoin risk. And most importantly, to encourage more risk-driven decisions rather than trend-driven or return-driven. The risk assessment framework further break the risk assessment into 8 different categories: asset backing, stability mechanism, governance, issuance and redemption, liquidity, smart contract, oracle, and regulatory risk. We believe that stablecoin, which has been assigned with the same risk values, exposed to similar type of risk. And then on a very high level, asset backing and stability mechanism are the two main areas have been used to describe how a stablecoin works. So in the rest of presentation, I'm going to focus on these two categories, but other categories are also important. The asset backing risk is the risk that the stablecoin may become under-collateralized when the asset that you use to back the primary value decline. So stablecoin project normally choose asset from one of the asset type here. Exogenous asset, which is the asset that have other uses outside the stablecoin system. Examples are Ethereum, Bitcoin, fiat, and other stablecoin. And then the other one is the endogenous asset, which the asset value arises from the stablecoin system itself, like equity in the system. Then the third type, some stablecoin used to have a design that was no explicit backing, and they rely on reward mechanism to adjust the supply and then to stabilize the price, but they are not here anymore, so I'm not going to the details of this category. For endogenous asset, the risk is that its value is derived from the stablecoin itself. When the demand is high, then the endogenous asset value is high. When the stablecoin demand is low, then the endogenous asset value is low. It will work when the market is good. But when there's crisis of confidence, the sell pressure on the stablecoin will trigger, may lead to both value going down together. So Terra is an example, but I want to mention that it does not mean all the endogenous assets are bad. So back in 2020, DAI did sell maybe 8 million of MKR to cover the shortfall. The fundamental difference is like in Terra's design, they use majority of its circulating value, majority of its primary value are backed by the endogenous Luna from the beginning. So when things happen, that all we know, they went into that spiral. So let's imagine like for a working stablecoin system, for every one new stablecoin, let's assume it's a US dollar pegged stablecoin, new stablecoin being minted, then it's supposed to have $1 US worth of asset to be entered into the stablecoin system. But for UST's design, for every new UST design, UST is minted, then $1 worth of Luna is burned. In this case, supply down and Luna's price goes up. Luna hold a benefit from the newly minted USD. So it is almost like a bank is using client's deposit to execute a stock buyback. This is more details on the exogenous asset backing mechanism. They normally choose from this asset type here. So stablecoin choose TradFi asset will expose to traditional market risk, as well as the custodian risk and censorship risk that we learned from the USDT peg. And then some may choose other stablecoin to back their primary value. So it will expose to the risk that the other stablecoin, there might be bad thing happen to other stablecoin, like other stablecoin depeg or other stablecoin has been seized by centralized party. That's what we learned from DAI. There are other cryptocurrency being used in the system. They are normally more volatile compared to the other two, and then used in the more often used in the leverage component, like Ethereum in Maker's MCD, or Ethereum in LUSD's Trove. This is an example of how the Swap framework assess asset backing risk. We have 6 risk factors defined: types, whether this is a custodial or non-custodial stablecoin, asset type, as I just discussed. And then we also have asset breakdown, validation of real-world asset location, and information quality. Please note that the USDC asset breakdown is not updated. It's kind of outdated here. For USDC, how they validate their real-world asset is they have a monthly attestation and annual audit. And for USDT, they have a quarterly attestation. And for DAI, since they use tokenized real-world asset, I still haven't figured out a way to find out how they validate it. So more work needs to be done there. And then for asset location, USDC's reserve is with US banks. And then for USDT, it's unknown. It's maybe Bahama banks. And then for DAI, you have the asset on-chain, and then for off-chain is for the real-world asset. Information quality, depends on how valid the information provided by the stablecoin project. For DAI, it's high because some of the asset is on-chain, it's all transparent. And then I haven't figured out for the tokenized RWA, so I put as a question mark. So let's talk about the stability mechanism. It is important to know about to analyze the stability mechanism of stablecoin projects so you know how they may fail to stabilize their value. On a very high level, stablecoin project use the reserve mechanism or the leverage mechanism to stabilize their value. They can choose either or use both. Stablecoin projects that use the reserve component in their design exposed to a similar risk, which is the risk that the stablecoin can become under-collateralized if the asset in the reserve component decline. Then for the stablecoin that also have a leverage component, the reserve component will help to mitigate the risk of short squeeze, but they will still experience the risk where if the collateral that used in the leverage component decline too fast, then the liquidation might become too challenged or too expensive to be executed. And then you have another type where you only have the leverage component. Then without the reserve component or without a negative rate setting, the stablecoin may have a risk to suffer from short squeeze, like the original DAI design before they have the PSM. This slide is about the governance risk. To understand what governance risks are stablecoin holder exposed to, you need to understand, firstly, who owns the governance process, how fast is the decision turnover, the level of decentralization and transparency, and what safeguards are there against bad governance. It is, for most of the stablecoin smart contract available, they are either controlled by trusted entity or they are upgradable, so that they can update their risk parameter later, or they can fix the smart contract if a programming bug has been identified. But it is also very important to have resilient governance designed to ensure that to prevent malicious player to have power to influence the decision-making process. For example, they make decision to benefit themselves by harming other stablecoin holder. So the current governance design normally adopt one of the design here. One is a trusted base. That's for all the custodial stablecoin. They have a trusted entity to control the decision-making process. And then the other one is by majority vote, like the DAO. And then the third one is the interesting one, where all the parameters are already preset in the smart contract. So there's no room for them to change after the smart contract been deployed to the mainnet. In this case, it's good that there will be no decision. Malicious player can't really influence the decision-making because there's no decision to be made. However, it has the weakness that if smart contract vulnerability have been identified later, they can't change it. Liquidity can exist both off-chain and on-chain. It's very difficult to accurately assess the liquidity off-chain without knowing all the relevant addresses. But for on-chain liquidity, you can have code set up to monitor liquidity at centralized exchange. And these are the two diagrams I created for my dashboard to monitor the curve tri-pool token holding and then the Uniswap USDC DAI balance. These are the other categories that also in the define the project. So issuance and redemption, it determines the stablecoin supply. Smart contract risk, programming bug and logical error in smart contract. I didn't identify a lot. There's not much exploit to stablecoin smart contract as of today, but it is very common for other DeFi protocol. And you also have the oracle risk, which is the risk of incorrect off-chain information being imported. And then at the end is the regulatory risk, the risk of changes in laws and regulation that may have negative impact to the stablecoin project. These are the past failure, a quick recap, and then most of them adopted a similar asset backing design. The challenge, I think the biggest challenge when you talk about stablecoin risk is how to assign an overall rating to the stablecoin, whether it's A++, 9 out of 10, 7 out of 10. The reason that is difficult because it's very difficult to judge the weight on different risk categories. And it can be biased depending on the person, the user's objective. And then it's also, there's not enough data to measure the probability of stablecoin default, so it's hard to assign score based on that. My concern is like having an overall score for a stablecoin, it might mislead a stablecoin holder that when they're using the rating, they're not aware of how the weight is assigned to each risk category. So our approach is to, rather than have to have an overall risk score, have a risk score for each risk category, and then the user themselves decide the importance of each category based on their own objective and risk appetite. Potential application can be help user decide which stablecoins they want to use based on the risk they are most worried about, help protocols decide which stablecoin to incorporate as collateral based on the risk the protocol that want to take or they don't want to take. And most importantly, stablecoin is one of the most important crypto application that can help to promote the adoption of the wider adoption of cryptocurrency in the general financial system. So it's very important to let the regulator to know that not everything is UST. There's a lot of good stablecoin design in the market. So this is what's more to come for my project. I will have a paper to list all the details, description of the chosen risk category, risk factor, and what metrics, how we use to measure them. Key stablecoin project overview, and then a doing dashboard, which is already done, to show live analytics that are used to monitor latest stablecoin market movement and on-chain activities. That's the end. Thank you.
Thank you, Tammy. We have time for 1 or 2 questions really quickly. All right, if not, then we'll get started in about 2 minutes with the next talk. Thank you so much, Tammy. Take care. Round of applause for Tammy.